Most people think geography is a trivia game, pointing at a globe, memorizing state capitals, knowing exactly where borders are drawn. But the discipline's true focus lies in its root, the Greek word geographos, literally meaning writing about the earth. It investigates a specific set of questions: what is where and why? While history attempts temporal synthesis, organizing events linearly along a timeline, geography attempts spatial synthesis. Our planet's surface is highly irregular. It's a chaotic overlap of towering physical features, intense weather systems, and dense human societies. To make sense of this global village, we have to look at it through a spatial perspective. We have to combine the physical sciences of the Earth with the social sciences of humanity. Let's start with the ground we stand on. We tend to view mountains, valleys, and plains as permanent fixtures. But these small to medium tracts of Earth, called landforms, and the larger landscapes they make up, are temporary. They are the result of intense geomorphic processes. First, there are endogenic, or internal forces. Deep beneath the crust, shifting, magma-driven pressures build the land up from within, pushing surface material upward. Then there are exogenic, or external forces. These environmental processes, like the impact of wind and heavy rain, break landscapes down, eroding them over time. Geographers map out these changing physical realities because they dictate where we can survive. The specific slope of a valley, or the mineral makeup of a plateau, determines where we can successfully plant crops, build infrastructure, and develop economies. The solid Earth provides the crucial base layer for human life. But that base layer gives us an incomplete picture if we don't look at the invisible atmospheric engine operating directly above it. The atmosphere is in constant motion, driven by global variations in temperature and pressure. High and low pressure zones create massive, shifting wind systems around the planet. As these winds drag across the surface of the oceans, they initiate and steer large-scale currents in the water below. This map shows major ocean currents acting as a global conveyor belt. Notice the specific types. Solid arrows, like the Gulf Stream, push warm water to higher latitudes. Dashed arrows, like the Labrador Current, return cold water, regulating the climate of entire regions. So, we have a continuous feedback loop. The Earth's physical landforms block and direct atmospheric weather patterns. In return, those weather patterns generate the rain and wind that erode those very mountains. The continuous collision of these deep Earth geological forces and large-scale atmospheric flows yields the exact environmental conditions that determine where humanity can thrive. Early human societies were entirely dependent on these immediate environmental factors. Today, we interact with and constantly modify those environments, altering the landscape to fit our needs. To track this dynamic relationship between humans and nature, geographers use modern tools like remote sensing and Geographic Information Systems, or GIS. GIS replaces static paper maps with digital computer mapping. It allows us to overlay distinct, isolated layers of spatial data to solve complex problems, starting with a foundational base. The first layer of data is the physical terrain. We map out the lithosphere, the specific mountains, valleys, and soil profiles that shape the ground. Next, atmospheric, climatic, and oceanic data are synthesized directly on top of that physical ground, showing us how the climate interacts with the terrain. Finally, the most complex variable is overlaid onto those physical and climatic realities: human demographics, sprawling city settlements, and interconnected economic networks. Geography is an integrating discipline. It provides a holistic framework for understanding how the physical forces deep below us, the atmospheric engine above us, and human actions all synthesize to create our reality.